Morning, everyone. My name is Todd Holmes. My project is the JCATI carbon fiber recycler, specifically the pyrolysis oven. Today I'll be going over the overview of what I've been working on for the past year. For starters, kind of background of this project, the previous oven of the machine was unwieldy and required considerable manual operation. So the main goal of this project was to design and manufacture a brand new oven that mitigated manual operation as well as included automation capability. With that sort of requirements that we set, I set a total of 13 requirements for the project, with the most important ones being the automation capability, the internal temperature reaching 500 degrees during operation, the pyrolysis operation taking 35 minutes or less, there being less than 5% oxygen within the oven during operation, as well as the external temperature not going above 35 degrees Celsius. To meet these requirements, analyses have been made for design parameters, and 11 analyses were made, one of them being for the automation capability, an electrical schematic just to conceptualize what needed to be done in order to create a good electrical system to account for automation. Another analysis was the heating element power. This one essentially is calculated what the minimum heating element power needed to be using Fourier's law. And that was given knowing the expected power input and anticipated preheat time. Third important analysis would be the wall thickness, which also used Fourier's law, just a different form of it. This used the expected internal and exterior temperatures just to calculate, as well as the ceramic fiber insulation, the thermal resistance of that, which calculated how thick that insulation needed to be. Knowing all these design parameters using analyses, we'll move on to the design and manufacturing of the oven. Most of the components were designed within the design phase or the fall quarter of the project, but it did spill a little bit into the winter quarter due to scheduling issues. The oven is mostly comprised of steel sheet metal, which was laser cut using CAD design patterns, and then bent to shape, welded at the seams to create shells, which the shells were then put together, fastened together with fasteners. And with insulation between those, that created the main oven body. Other than that, other components like the conveyor components here, made of aluminum seat channel for the steel rods in between for the axles. Those are made out of aluminum and steel stock using band saws, engine lathes, and the end mills to cut these pieces to shape to manufacture the parts. In addition to that, the automation component of the oven required considerable wiring and programming of a PLC, as seen on my left here. It took a lengthy amount of time to figure out how to do so and make sure that the system would work correctly for my purposes. Some issues that came up during the manufacturing phase were the biggest one being there was one component where I misread the calipers and ended up turning down a piece too far, and that was the last piece of that stock, so I had to figure out another solution or a different piece of stock to fix that. Other than that, the cutting tools in the Hogue machine shop are less than ideal, so there was a couple moments where I took some time to just find something that would suit my needs. And then less of manufacturing, but also an issue with shipping delays during manufacturing phase, just added more delayed time to assembling the whole thing. Now moving on to, also, this is the drawing tree, which just kind of covers most all the parts. There were 57 parts total in this oven. So Moving on to the testing of the oven to make sure that the requirements are being met. Multiple tests were made. There's three most important tests. First one being the preheat test. This is a test that kind of evaluates whether requirements 5 and 12 are being met, which are the oven reaching 500 and external temperature not going above 35 degrees. This is a time test. It's a 60-minute test initially, with every 5 minutes temperature reporting being made up until 5 minutes, or up until 60 minutes, or until it reaches 500 degrees internally. It was predicted for 10 minutes for the oven to preheat to 500, although this was blown wildly out of proportion, as it took 92 minutes instead, as seen on this graph here. It's the orange line, which raised concerns with the wiring or the capability of the heating elements. In addition to that, the external temperature, the requirement 12 set it to 35 degrees Celsius maximum, but it did end up reaching nearly 150 degrees Celsius, also breaking that requirement. Moving on, the results from this test necessitated an immediate response test set, essentially looking into the capabilities of the heating elements, making sure that they're working as intended, that they are running on the rated power that they claim to be. Essentially all this is a resistance and amperage test from within the PLC there, using a multimeter to probe certain wires. The predictions of the resistance and amperage met the actual results, which meant that the heating elements were working just fine as intended. It just meant that these heating elements were underpowered for their intended purposes. So therefore, a new heating element has to be replaced with them. Most pertinent test would be the candle test, as I like to call it. It is essentially just, this one is going into requirement 12, making sure that the internal environment is less than 5% oxygen, make sure that nothing combusts while during operation. And all this is me running the inert gas and seeing how long it takes for the candle to get snuffed out. So right here is a little bit of this is one trial test. It lasts about 40 to 50 seconds. Just go to the end here. You can see it gets dimmer and dimmer until it finally gets extinguished. And that's just from argon being pumped into the oven. Now to end off here, go into the results of the test mostly. Actually, no. We have the budget and schedule first. Real quick, the budget was around $5,000 total of a grant given to me, and this was to use any funds that pertain to the project we could use. It was exceeded by $99 roughly at the end, just by one last part. And this is an itemized list of everything that was purchased for the project right here. Other than that, the schedule, a Gantt chart was used to help track down certain tasks. And these are all we have the design phase, construction phase, and evaluation phase with different pages. Scroll. Oops. At the end, the project is not quite complete, but it's an estimated that 210 hours will be spent into this project. And with that, now to go to the conclusion. The main results, many of the requirements were not met. However, I believe this project was an ultimate success, as the most pertinent requirements, the ones pertinent to pyrolysis were met, as well as this oven is now created with. It was a good foundation for the next student to go off of. And with that, that concludes my presentation. Are there any questions?